In this video, we shift our focus to the fascinating world of machine learning, the engine powering much of today's AI. ML enables systems to learn and improve from experience without being directly programmed. We'll explore three main types: supervised learning, unsupervised learning, and reinforcement learning. At the dawn of AI as a field, there were two approaches to solving AI problems: machine learning and expert systems. Expert systems rely on predefined rules, like a fixed recipe. They're great for simple, predictable problems, but they struggle when faced with anything unexpected. Machine learning, on the other hand, learns patterns from data, adapting and improving over time. Instead of following rigid rules, machines analyze examples to figure out patterns and make predictions. For instance, you can train a model to identify cats and dogs by showing it labeled images. The key difference between machine learning and expert systems is how they handle problems. While expert systems use static, human-programmed rules for predictable tasks like diagnosing specific medical conditions, machine learning's ability to adapt and learn from data makes it ideal for dynamic, complex challenges like image recognition, personalized recommendations, or detecting fraud. Machine learning uses algorithms to learn from data. These algorithms come in different types of tasks, each playing a unique role in helping machines learn. Let's take a closer look at the three main types of machine learning algorithms and how they work. First, supervised learning is like teaching with examples. Think of it as a guided learning process where the system learns from labeled data. For instance, if we want to teach an AI model to recognize cats and dogs, we show it thousands of images, each clearly labeled as either a cat or a dog. The system learns patterns in the images to make predictions about new, unseen examples. This method works exceptionally well for tasks like spam detection, where emails are labeled as spam or not spam, or predicting house prices, where we have data like square footage, location, and price. The key here is the availability of labeled data. Next, unsupervised learning is about finding hidden patterns in unlabeled data without predefined categories. Imagine looking at a collection of photos of different animals and grouping similar ones together without knowing what the animals are called. The system uses the data's inherent structure to cluster or organize it. This is incredibly useful for tasks like customer segmentation, where we can group customers based on their buying behavior to tailor marketing strategies, or anomaly detection, such as spotting unusual transactions and fraud detection. It's like being an explorer in uncharted territory, discovering relationships and patterns on your own. Finally, reinforcement learning is a bit different. It's learning by trial and error. Think of a robot learning to walk. It tries various movements, gets feedback, a reward or penalty, and adjusts its actions to maximize rewards over time. This feedback comes from the environment the AI interacts with. For example, sensors might indicate whether the robot stays balanced, reward, or falls, penalty. This approach mimics how humans often learn through experience and consequences. It's widely used in games like teaching AI to play chess or Go, robotics, where machines learn to perform complex tasks, and self-driving cars, which learn how to navigate safely through traffic. The exciting part is that the system learns dynamically by interacting with its environment, making it adaptable and robust. To better understand how different ML algorithms work, let me tell you a story about learning a new language. Imagine you've always been curious about a foreign language, so you decide to enroll in an intensive course to master it. On the first day, you're handed a well-organized textbook, complete with vocabulary lists, grammar rules, and exercises. Your teacher guides you through each topic, giving you homework and correcting your mistakes. For example, you practice translating sentences like, "The cat is on the table," and your teacher points out where you went wrong. This part of your journey is structured, methodical, and filled with clear feedback. It mirrors supervised learning, where machines are trained using labeled data. Just as your teacher provides the correct answers to your assignments, a supervised learning algorithm is fed inputs, say images of cats, and their corresponding outputs, the label cat, during training. This approach is great for tasks like recognizing objects in images or predicting house prices. After a month of lessons, life takes an unexpected turn. You meet someone whose native language is the one you're learning, and you quickly hit it off and fall for each other. Now your learning happens through immersion. You talk to your partner every day, watch TV series in their language, and figure out what the labels on groceries mean when you go shopping. Nobody explicitly teaches you the meanings of new words or phrases, but you start to notice patterns. For example, words with similar endings often mean the same type of thing, like describing colors or emotions. This phase is like unsupervised learning, where machines explore data without labels. They uncover hidden patterns or group similar things together. Just like you learning to categorize new words, unsupervised learning algorithms are used for clustering customers with similar preferences or finding anomalies in data. Your relationship grows stronger and you decide to journey to your partner's home country to meet their family. However, the journey takes an unexpected twist. A storm wrecks your ship, and you find yourself stranded on a remote island. The island is home to a community of people who speak a completely unfamiliar language. Now, your survival depends on communication. You attempt to ask for food, but your gestures and sounds don't always get the desired response. Sometimes they hand you a bowl of food, a reward, and other times they ignore you or frown in frustration, a penalty. Through trial and error, you start to understand how to express your needs. You learn that a certain sound combined with a specific gesture works better than others. Slowly but surely, you adapt and refine your communication skills to maximize positive outcomes and avoid negative ones. This stage of your journey mirrors reinforcement learning, where machines learn by interacting with their environment. They take actions, receive rewards or penalties, and adjust their strategies to achieve better results over time. It's the kind of learning that powers self-driving cars, trains robots, and teaches AI to master complex games like chess or Go. In your language learning journey, each stage represents a unique way machines learn. Structured lessons with clear feedback resemble supervised learning. Immersion and pattern discovery parallel unsupervised learning. Trial and error with rewards and penalties mirror reinforcement learning. These methods show how machines, like you, can learn and adapt to challenges in different ways. We've just explored the key differences between expert systems and machine learning in AI. While expert systems use predefined rules for predictable tasks, ML learns patterns from data, making it adaptable to complex problems. It covers the three main types of ML: supervised learning, where models learn from labeled examples for tasks like spam detection; unsupervised learning, which discovers patterns in unlabeled data for clustering and anomaly detection; and reinforcement learning, which learns through trial and error for dynamic tasks like robotics and self-driving cars.